Hello students, these are the topic tests that we at Bodhee Prep have for you for the quant section. Now, the idea of these tests is when you cover the basic concepts of a topic, you can take the related tests on that topic to see whether you're able to apply those learned concepts in a test or not. With every test, there is a video. So after you've taken the test, you refer to the video, you get all the solutions and a brief analysis of how the test should have been attempted and what was a good attempt. There are more than 200 such topic tests available on the Bodhee Prep Android app. So you can, the link for which is in the description. You can download that app and make the most of these tests. This video is on the topic progressions, and this is the first test on topic progressions on the app. Overall, the test is, I think, a moderate sort of a difficulty level, and about 6 to 7 questions net correct would give you a 95 plus percentile easily. The attempt time for this test would be somewhere around the 20-minute mark. 20 to 22 minutes should be the ideal time where you're able to go through all the questions and get your 6 questions correct. If you look at the questions, the first one says a1 minus a2 plus a3 minus a4 is up till minus 1 raised to power n minus 1 an is n. Therefore, a1 is nothing but n, which is 1. a1 minus a2. Now here n becomes 2, so this is 2. But we know that a1 is 1. Therefore, 1 minus a2 is equal to 2, which means a2 becomes 2 minus 1 with a negative sign minus 1. a1 minus a2 plus a3 is n, which is 3 now. This is 1, this is minus 1 plus a3, which is 3. So a3 will come out to 1 plus 1, 2, 3 minus 2 is 1. And so on. So if you look at the series, all odd terms will be 1 and all even terms would be minus 1. It says, what is the value of a51 plus a52 plus a53 and so on. Now, if we add a odd term and an even term, we will get 1 minus 1, which is 0. So a51 plus a52 will be 0. a53 plus a54 will be 0 and so on. So every odd and even term will cancel each other out. The only term that will remain in the end will be 81023, which is an odd term. And the value of this is 1. So this total sum will add up to 1. Option D becomes the answer. The question is not difficult. At best, a moderate level of difficulty in 2 minutes. Solving time should be good enough to manage this question. Consider the sequence where the nth term Tn is n upon n plus 2. N can take values of 1, 2, 3, 4 and so on. We have to find the value of T3 into T4 into T5 up to T53. T3 will be nothing but 3 upon 3 plus 2, 5. T4 will be 4 upon 4 plus 2, 6. T5 will be 5 upon 5 plus 2, 7. T6 will be 6 upon 6 plus 2, 8 and so on. The last few terms will be T51, for example, will be 51 upon 53 into 52 upon T52 upon 54 into 53 T53 upon 55. Now, if you look at this, the first and the third denominator numerator cancel. Similarly, the 6 of 4 by 6 and 6 by 8 cancel out, and 7 will cancel out, and so on. The last denominators to be cancelled out will be 53, and therefore we'll have the first two numerators left and the last two denominators left. So 55, sorry. And therefore the net answer will be 3 into 4 upon 54 into 55. Now this is nothing but 18, 3 18s are 54, 2, 9. And therefore the answer becomes 2 upon 9 into 55, which will be 495. So option A becomes the answer. This, I think, is an easy question, should not take more than a minute and a half to solve. The values cancel out and we just have to find the product. If 7 raised to power 1 by p is equal to 49 raised to power 1 by q is equal to 2401, this is 7 raised to power 4. In raised to power 1 by r, then pq are r in. So if we want to compare powers, first of all, we make the base the same. 49 becomes 7 square 1 by q. 2401 becomes 7 raised to power 4 1 by r, which means 7 raised to power 1 by p is equal to 7 raised to power 2 by q multiplying the powers is equal to 7 raised to power 4 by r multiplying the powers. Since the bases are same, we can say 1 by p is equal to 2 by q is equal to 4 by r. Let this be equal to, say, k. So from, or 1 by k. where k is a constant. 1 by p upon being equal to 1 by q, we can say p is equal to k. 2 by q being equal to 1 by k, we can say q is equal to 2k. And 4 by r being equal to 1 by k goes to the top, r goes to the top, r becomes 4k. And therefore, if we look at PQR, we see they are k, 2k and 4k. Clearly, 2 is being multiplied from the first to the second term, second to the third term. And this is a property of a geometric progression. The common ratio is same. 2k by k is equal to 4k by 2k, or 2k is the geometric mean of k and 4k. Again, since the powers are have to be used, I'm calling it a moderate question, but solving time will not be very high because we get a pretty straightforward relationship uh, which should not take too much time to solve. The nth term of a series an is n minus 1 by 2 if n is odd, n by 2 if n is even, and a2 into a3 plus a4 into a5, and so on till ak minus 1 into ak 650. What is the value of k? Now a2 will be nothing but n is 2 here, so 2 by 2. This will be 2 minus 1 by 2. 3 minus 1 by 2 because n here n is 3 plus 4 by 2 even into 5 minus 1 by 2 a5 odd plus 6 by 2 2 3 4 5 6 into 7 minus 1 by 2 odd and so on. Every time the first term is even, so this will be even, so k minus 1 by 2, sorry k this will be k minus 1 by 2, k minus 1 is even, which means k is odd, into, since k is odd, we'll say k minus 1 by 2. So if we look at it, this is 2, this is 1 into 1 plus 2 into 2 plus 3 into 3 and so on till k minus 1 square, k minus 1 into k minus 1. This is given as 650, k minus 1. And therefore the expression that we get is 1 square plus 2 square plus 3 square up till k minus 1 whole square is equal to 650. Now here we can put the formula for k minus 1 whole square, the sum of squares of the first and natural numbers, which is n into n plus 1 into 2n plus 1, 2k minus 2 plus 1 will be 2k minus 1, n into n plus 1 into 2n plus 1 upon 6. This is 650. Or it may not be a bad idea to simply put the values from the options. Since k is odd, k cannot be 12 or 24. Here what we'll do is we'll look at three numbers which have a cube. We'll do that separately. Now if you put k as 13, we get 12 into 13 into 26 minus 1, 25 by 6. 6 2s are 12. 2 into 25, 50. This gives us 650. And therefore, we can say that k is 13. Putting the value, we're getting the answer. Option B. If you put k as 25, 24 into 25 into 50 minus 1, 49 upon 6. Clearly, this will be a very large number, which is 4900. So we will not go there, and therefore k is 13. If I had to solve this directly, what I do is 2k minus 1 will be approximately double of k minus 1. So we'll look at three numbers and divide this by 2, roughly speaking. And therefore, we look at three numbers whose product is very close to, 650 into 3, which is 0, 5, and 1, 9, 5, 0. So look for an x cube which has a cube close to 1950. We know that square of 12 is 1728. 13 therefore will be pretty close, and therefore we can check for 12 and 13, putting values and getting the answer rather than trying to solve a cubic equation. Now in terms of level of difficulty, I would say moderate level of difficulty question, because forming the this expression might take a bit of time or could be a little difficult. Once this happens, we're just putting values, and therefore the question I think should be managed in about 2 minutes. A1 is 1, an plus 1 is 2, an plus 5. So if a1 is 1, A2, putting 1, n is 1 here. A2 will be 2A1 plus 5, which means 2 into 1 plus 5, which is 7. A3 will be 2 into A2 plus 5, which will be 2 into 7 plus 5, which is 19. The difference here is 6, then is 12, and so on. Now, if we look at the options and try to get the value of this is A1 as 1, we can say from the options 5 minus 6 will not give me, will give me a minus 1. 5 plus 6 will be 11. 6 plus 5 is 11. So I'm looking at the last term. We are looking for A100. Here every power of 2 is 99. Therefore, for 2, we can say 2 will be to the power n minus 1. So if we put n as 1 here, for all of these options, the general form for the term A1, 2 becomes 2 raised to power 0, which is 1. We need 1, which we can get from 6. And therefore, what I'm saying is, if we write this as 6 into 2 raised to power 0 minus 5, this as 6 into 2 raised to power 1 minus 5, this as 6 into 2 raised to power 2. 24 into 4 into 6, 24 minus 5 is 19, and therefore the general form of an becomes 6 into 2 raised to power n minus 1 minus 5. So what I've done is, by putting looking at 99 being 100 minus 1, the power of n 2 becomes n minus 1. Put 1 as n, this term disappears. Then just from the option C, which option is giving us a 1? 6 minus 5 gives us a 1. So we fit the value for that, and therefore A100 will be nothing but 6 into 2 raised to power 99 minus 5, option D. And therefore, in terms of level of difficulty, definitely moderate to difficult. Getting the expression sometimes is difficult. There might be a case where more than one option might satisfy one value, so you'll have to check for more values as well. But in this case, for the specific question, because the value is simple, A1 is equal to 1, I think 2 minutes, 2.5 minutes should be good enough to answer the question. A1 is equal to 3, A2 is equal to 7, An is equal to 3n minus 1 minus 3n minus 2. So if you put n as 3, we'll get A3 is equal to 3A2 minus 2A1, which is 3 into 7 minus 2 into 3, which is A3 becomes 21 minus 6, which is 15. If we look at A4, this will be 3 into A3 minus 2 into A2, which will be 3 into 15 minus 2 into 7, 45 minus 14, 31. So this is how the process is going on. We can keep doing this till A8, but if we try to look at a pattern, the values are 3, 7, 15, 31, and so on. The difference here is 4, the difference here is 8, the difference here is 16, which are powers of 2. So we start adding powers of 2. This was A4. So A5 will be 4, 8, 16. Add 32. A6 will be add 64. A7 will be add 128. A8 will be add 256, basically. But another thing that we are able to see here is 3 is nothing but 4 minus 1. 7 is nothing but 8 minus 1. 15 is 6 minus 16 minus 1. 31 is 32 minus 1. This is 2 raised to power 2 minus 1. 18, 8 minus 1. 2 raised to power 3 minus 1. 2 raised to power 4 minus 1, and so on. And therefore, we can say that the general term here is an, which is for 1, the power is 2. For 2, the power is 3. So 2 raised to power n plus 1 minus 1. We have to find A8. This will be 2 raised to power 8 plus 1 minus 1, which will be 2 raised to power 8 plus 1. 2 raised to power 9. 512 minus 1, which is 511 becomes my answer. If you're able to spot this term, I think the calculation is easier. Otherwise, also, we're just adding these numbers from 3, 4, 8, 16, 32, 64, 120, 256, which will still come out to 511. I think moderate level of difficulty questions, because the pattern is powers of 2, should not be very difficult to spot. And again, about 2 to 2.5 minutes to solve this question. Find the value of s. S is given by 5 by 2 plus 13 by 6, 25 by 12, 41 by 20, and so on. The difference here is 8, 12, 16. So the difference is increasing by 4. Something like that. If you look at the denominators are 2, 6, 12, 20. Now this series is common. 2 is 1 into 2, 6 is 2 into 3, 4 is 3 into 4, and so on. So basically, these are the products of two consecutive numbers. Also, we see that the denominator is less than the numerator in all cases. So what we can do is we can start dividing. 5 by 2 will be 2 plus 1 by 2. 13 by 6 will be 2 plus 1 by 6. 25 by 12 will be 2 plus 1 by 12. 2 plus 1 by 20, and so on. The last term will be 2 plus 1 by 2450. How many terms are there? This is 1 into 2. 2450 is 49 into 50. 5 for 2. This is 49 into 50. So starting from 1, 1 into 2, 2 into 3, 3 into 4, 4 into 5. The last term is 49 into 50. Therefore, there are 49 terms in total in this series. So we will have, for every term we have a 2. So we have 2 into 49 plus 1 by 2 plus 1 by 6 plus 1 by 12 plus 1 by 20 up to 1 by 2450. This series can be broken down as 1 by 2 is nothing but 1 minus 1 by 2. 1 by 6 is 1 by 2 minus 1 by 3. 1 by 12 is 1 by 3 minus 1 by 4. 1 by 12, this is 1 by 20. Is 1 by 4 minus 1 by 5. And so on. The last term will be 1 by 49 minus 1 by 50. Minus half plus half cancel, minus 1 by 3 plus 1 by 3. These terms all will cancel out. We'll have the first and the last term left. This is 98 plus 1 minus 1 by 50. So this will be 98 into 50 will be 98 into 50. 45, 4900. 4900 plus 1 plus 5. 4900 plus 5 minus 1 plus 50 minus 1. 4900 plus 50 minus 1 upon 50, which will be 4949 upon 50. Option C becomes the answer. Again, I would not say this is a difficult question because this series in the denominator is something that is common, and you would have done questions on this series while practicing. And therefore, I think maybe a doable question. The attempt time might go high because there are multiple steps involved. About 2.5 to 3 minutes to solve the question. S is 1 square minus 2 square plus 3 square minus 4 square and so on till 2001 square. So if we write the positive terms, we'll have 1 square plus 3 square plus 5 square and so on till 2001 square minus 2 square plus 3 plus 4 square plus minus I've taken common plus 6 square up till 2000 square. We know the square of the first n natural number. So what I'm doing is I am adding and subtracting these terms again. So we'll get 1 square plus 2 square plus 3 square plus 4 square plus 5 square and so on till 2001 square minus this will be subtracted twice now. So what we have done is we have added and subtracted 2 square plus 4 square plus 6 square and so on to complete this series from 1 to 2001. Now, if you look at it here, if we take out 4 from 2 square, we'll be left with 1. If we take out 4 from 4 square, we'll be left with 2 square. If we take out 4 from 6 square, basically 6 square is 6 into 6, which is 2 into 3 into 2 into 3. We are taking out 2 and 2, 4, so we'll be left with 3 square. So basically, from the bracket, from each term, we can take out 4. So this becomes 1 square plus 2 square plus 3 square up till 2001 square minus 2 into 4 into this will be 1 square, 2 square, 3 square and so on up till 1000 square. Now both these terms are of the form where we have sum of the first n natural number squares. This will be n into n plus 1 into 2001, 2n plus 1, 4002 plus 1, 4003 upon 6 minus 8 into n plus 1 into 2n plus 1 by 6. uh, 1001, 3, 3, 6 are 18, 20, 667. This will be 667 into 1001 into 4003 minus 2 2s are 4, 2 3s are 6. This will be 667 minus 667 into 1001 into 4000 into 4 into 1000. This is 667. We can take the 667 common and 1001 goes 667 into 1001 into 3. 4000 minus 4. 667 into 3 is 2001 into 1001. This will be nothing but 2001 2001. This will be 200301. Multiplying 2001 by 1001, we'll get 200301. So you can multiply, if this is not clear, 2001, 1, 2, 3 crosses because 3, this is the thousandth place, and then 2001. Add to get 2003,001, or 2001 into 1000 plus 2001, we get this answer. Again, I'd say moderate to maybe difficult level of question because completing the series is something that we'll have to figure out. Once that happens, attempt time will also be on the higher side because calculation is there, a little bit of it is there. Please stop the years to multiply the numbers at this stage. Take out the common values, the calculation then is a lot easier. S is 1 by root 1 plus 1 by root 1 plus root 5, 1 plus root 5 plus root 9 and so on. What is the value of S? The sum we have to calculate. Now, whenever we have these kind of denominators, the first thing that we do is rationalize them. So, the first term can be multiplied by root 5 minus root 1 upon root 5 plus root 1 into root 5 minus root 1. Multiplying and divide by the conjugate. Second term becomes root 9 plus root 5 upon root 9 plus root 5. This is minus multiplied by root of 9 minus root of 5 plus root 13 plus root 9 minus root 9 upon root 13 plus root 9 into root 13 minus root 9. Multiplying by the conjugate, the last term will become root 121 minus root 117 upon root 121 minus root 117 into root 121 plus 117 is what we will get. Now the denominator becomes a plus b into a minus b, which will be root 5 minus 1, root 1 is 1, into upon root 5 square minus 1 square, which is 5 minus 1, plus root 9 minus root 5 upon 9 minus 5, plus root 13 minus root 9 upon 13 minus 9, and so on. The last term will be root 121 minus root 117 upon 121 minus 117. So all of these denominators become 4. So we can add the numerators 5, root 5 minus 1 plus root 9 minus root 5 plus root 13 minus root 9 and so on. The last terms will be root 117 minus root 113 plus root 121 minus root 117. There is a difference of 4. 5 minus 5 cancel, 9 minus 9 cancel, 13 and so on. Lastly, 17, 113. Root 117 and 117 will cancel out. So we'll be left with root 121 minus 1 upon 4. The second term of the first, the one from the first term and root 121 from the last term is left. Root 121 is 11. So 11 by 1 minus 11 minus 1 by 4, which is 10 by 4, or 2 by 10 by 4, which is 5 by 2. Divided by 2 becomes the answer, which is none of the options. Hence option D. The question is easy. Writing it takes a bit of time, but while solving, we don't have to really write it. We just have to rationalize the terms, which can be done directly, and we can directly come to this step from where we can cancel out the negative values to get the first and the last value. This question says x1 is 1, x2 is 2, and xn plus 1 is defined as xn into xn plus 1 minus 1, where n is a natural number. You have to find the value of x100. So x1 is 1, x2 is 2 is given to us. Now we'll build the series. X3 will be, if we put n is equal to 1, x1 into x2 minus 1. So x1, which is 1, into 2 minus 1, which comes out to 1. x4, if we look at it, x4 will be, if you put n is equal to 2, x2 into x3 minus 1, which is 0. x5, if you look at, this will be putting in s3, x3 into x4 minus 1, which is minus 1. x6 will be x4 into x5 minus 1, which will be 0. x7 will be x5 into x6 minus 1, which will be 1. x8 will be x6 into x7 minus 1, which will be 0. 1 and 0 we see are repeating. x9 will be, again, for writing x9, we'll use 1 and 0 in this order itself. So beyond this point, the pattern will repeat. So x9 will be 1 into 0 minus 1, x7 into x8 minus 1, which is minus 1, 1, 0 minus 1, 0, 1, 0 minus 1, x10 therefore will be 0. So the pattern repeats. x1 is 1, then we have 2, then we have 1, 0, minus 1, 0, minus 1, 0, and then these four numbers will repeat 1, 0, minus 1, 0, and so on. We have to find the value of x100. Now, this term is x6. This term is x10. It is repeating after intervals of 4. So if we keep adding 4 to it, the multiple of 4, 3, 4, 5, 6, 7, 8, 9, 10. Multiple of 4 is 88. If we add 88 to it, x98, that is 10 plus 88, will also be 0. 1, 0, minus 1, and then this will be the x98 term. The next two terms will be 1 and 0. This becomes the 99th term. And therefore, this will be the 100th term. So x100, the value is 0, and that becomes my answer. Overall moderate level of difficulty. 6 to 7 rated questions correct for 95 plus percentile. 20 odd minutes to solve. My 7 questions or 6 questions that I would attempt in this kind of a test would be 1, 2, 3, 5, 6, 9, and 10. Which are these ones? Definitely doing this one, we're getting ones and minus ones, which will cancel out to leave only one term. This is a pretty simple term. Just put the value of and multiply. Again, this was not very difficult in the sense that once you equate the powers, you get a simple ratio, and the answer was simple. It was not a HP which creates confusion. APGP answers tend to be easier. Here, there is a chance of mistake happening because solving k minus 1 into k plus 1 upon 6 was a bit of a challenge. And not always we are able to think of the options. So yeah, I will not count it as an attempt question. This, I think, for me was an attempt question because we've done similar questions earlier. This also, the series was simple, powers of 2, so I'm counting this. Unless you know the series 2, 6, 12, 20, might not be an attempt question for everyone, so not counting this. This, I think, again, the calculation was involved, and it might not be clear as to what are numbers to add and subtract, so not counting this as well. This I'm counting because the standard question, I have done such questions earlier, and for this kind of an expression, the first thing that you have to do is rationalize. The moment you rationalize by multiplying the conjugate, you realize that the other steps kind of follow. So counting this question, I'm also counting this question as an attempt question for the simple reason that here all we have to do is find the pattern and the repetition will happen. It happens for these questions, and typically the repetition is at max steps of 6. So since we've done questions earlier which are similar, therefore for me this is an attempt question. Hence my attempt would be 1, 2, 3, 5, 6, 9, and 10.